So this video is about solving equations algebraically. What we mean by that is that we've learned some of the methods of solving equation, linear and quadratic or of that type by hand, and this one will produce a solution of that type, some exact answer solution. So this is how the equation is typed in, the usual expression, and as you can see there is a 2 equal symbol there, 1 equal symbol and 2 equal symbol, and together it makes an equation. If it is 1 equal symbol, it's an input command. So this makes an equation, and solve is the command. So like this, if you put solve around it, and this part is going to be equation, and we're solving this equation for x, example like this. So that's if you execute this one, and it's going to find the solutions. So you see this listed out as a substitution rule. X is the substituted with 1 minus, so 3 times square root of 2. And second solution set is 1 equals x is substituted with 1 plus 3 times square root of 2. That's the way they output the equation of a solution of an equation. If you want to use this number, you can simply copy and paste or rewrite and retype to use it. But you can also use the command and list command and type of thing to kind of get this one out. Remember, this is not a number, this is a substitution rule. To use it, you have to use the substitution method, for which I made a video already. So that's what I'm going to show. So I inserted there, as you can see, this entire thing is going to be this one. As you can see, it's a list of a list, right? So for example, the solution will be a list of substitution rules. So the first substitution rule has this x value, and the second substitution rule has this x value. So I'm going to execute it, and then it shows what the solution is. And if you retype a solution here, it's going to reproduce. But if you want the first bit, if you remember, if you execute this, then it's going to show you this substitution rule. And of course, if you change that to 2, then it's going to show the second substitution rule, right? So if you want to use that, okay, I want to plug this x into something else. For example, if you want to plug in, let me run this one so that it does. If you have this expression and you want to plug in this one of these x values here into this formula and see what value you get out of this one, and that kind of thing, we do it a lot. So we have this formula. Go to the next slide. So to plug in something a value of x into here, this is substitution rule. X must be something. For example, if I put 3, then it's going to show this value, sine 3 divided by 15. If you change that to 3 point, then it's going to show you the numerical solution. That's how you put this x value in, and this is a syntax for the substitution rule. So as you can see, this part here itself is already the substitution rule. So if you want to substitute this x value, it has to be this substitution rule. The solve itself is a list of 2 substitution rules. So if you want to pick one, you have to do this selection of an item. Then if you do that, and it's going to give you this exact value. You can do lots of parts and go to the next line and try to simplify the previous result, and it's try to simplify as much as you can. Or there are different options such as expand, and then let's try to do something. So I like to simplify. So I'm back to simplify, and that's one of the things you can do with this thing. So if you go back and change to the second solution, and it's going to use the second substitution rule, shift enter like this. So what it's showing here is just some tips. It's not really anything to do with this solving equations, or it's useful. We're more used to the writing the quotient in the vertical way, and many other notations are okay. You can just line a linear way of expressions, fine, but sometimes quotient is better expressed in that way, and I'm going to show you and how to type that vertically like this, kind of useful command. So I'm going to go to the next line and retype it so that I remember. So formula here again, I'm redefining it. So if you're about to type a quotient, then you hold Control key and slash, forward slash. Then it generates numerator and denominator. Then you can just type in there numerator and use arrow key to get down there, and plus x plus 3. And go to the end and change to that. I'm going to delete that one. So this is a way to kind of writing it nicely and vertically, and that's there's a way to write the superscript and everything, but I think this is one thing useful I'd like to mention. But this is not that confusing, so I usually just use this symbol for the superscript. So that's a basic example, and I'm going to show you next example of solving equation algebraically. That this is one equation, but next one is a system of equations. Right, here's, for example, I call this 3 equation like this, 3x minus 3y plus c. So you can see I tweaked a little bit, but it's not linear. I have this square right there. So these are the 3 equations, 3 variable. Maybe there are finitely many solutions. So let's just solve this one. So this is not yet an equation. You have to set this one equal to something. So I chose an arbitrary. It's one equation values. Formula 2 is set to 0, and formula 3 is set to 1, and formula 4 is set to 1 again. Remember, these are double equal symbol to make an equation, and this is a list of an equation. For that we have to use this curly brace. So solve list of equation with this parenthesis around it, and then you have to indicate which variable you're solving this for. So x and y and z, so you have to put in parentheses again. So this is how you solve a system of equations in algebraically. And again, you try to solve it, and often if you just put a random equation, and even Mathematica does not know how to solve it exactly. This has to be some special equation for which we have mathematicians know how to solve that kind of equation. So again, this is algebraic solution, exact solution there. It's very, very limited. But if you know it's solvable and you want the exact answer, then this is how you do it. I already showed you that this is going to be a list of solution and substitution rule, and all stored in this named SOL. So I want you to try this one yourself and see what kind of output you get. Alright, this is what it gave me. This is just a PDF file. So you can see the first element here, first substitution rule says x is substituted with this value, and y and substitution rule, and z substitution rule. So that's the first solution represented as a substitution rule. And second solution here represented again as a substitution rule. So there are 2 solutions. So namely, there are 2 sets of solutions of x for x and y and z. So this is an exercise that the SOL is 2 solutions, and if you want to just name each of the solution a different way, and you can redefine it with a different name, SOL1, SOL2, then you choose these elements, and then it's going to show you these 2 results. And if you want to use this one again, and like I showed here, I have this x and y and z, and I want to use this x and y and z value to evaluate this expression, and this SOL1 itself is already the substitution rule with the parentheses around it. So formula 5, this 1 point, is way to turn everything into numerical value because it involves the sine and cosine in here. It might just keep it in the sine and cosine, so this one will change it to numerical value. So again, this is syntax / dot of the substitution rule that we named it as a SOL1, SOL2. If you do this, and it's going to show you the numerical value of this formula with x and y and z given by this exact value. So those 2 values turn out to be this one. So these are 2 examples of solving equation exactly. Again, this is very limited, and if you just try some equation, you grab it and try this solve method, and Mathematica will likely suffer and have difficulty to solve it exactly. When you use the solve command, you know this is solvable, and you know exactly solvable, and you want the exact solution, then you can try it. Most of the time we're going to use a different method, something looking for numerical solutions, which will be the next part of the video.